Okay, so this is about solving equations with matrix. So what we've done so far has been some addition and scalar multiplication. So I would just take it one piece at a time. So I would probably go ahead and multiply matrix A by 3 and write that matrix out. Some of you probably won't need to do that. I think it helps you keep up with what you've got and what you're going to do. And very easy to make a mistake when you've got so many components to something. Then we're going to add to that half a B, and I would go ahead and take half a B and put those in the matrix. Okay, so that's pretty simple, and then you can do your adding or subtracting, whatever you need to do. Okay, so I would take it one at a time and just make sure, oh, that's a positive 9, make sure I know what my operations are and that I have taken care of these small things here first as far as distributing so that I can do the adding and subtracting without much difficulty. Okay? So, you will get more complex problems than that. You are probably going to get something that looks like this. And you are looking for a whole matrix after all of these operations are done. So this is where I really would be careful and I would make sure I'm doing each step. So we want this matrix X, but we're going to multiply A by 2. And I probably could go ahead and multiply that out. This is just me wanting to be exact in what I'm doing. So most likely, if I were doing this, I would just write it all out first to make sure that I've got all my components where they need to be and I'm going to be doing the right operations. So then I would distribute this negative 2. So if I distribute the negative, this becomes a positive, right? Just going to make it decide what we get, and then I'm going to go ahead and distribute this 1/2 or 1/3, excuse me, and get my matrix there. Okay, and then like before, because we're adding this matrix, we're just going to subtract it over here so that we can just move this whole matrix over. Okay. And now I want to do my subtraction here. Negative 3 plus 12 is positive 9. Negative 1 plus 2. Oh, sorry, put a plus in there. Is a 1. And then negative 4 minus 4 is 0. And 3 minus negative 12 is 15. Alright, and then the only thing left to do is because this X had a negative in the front, we're just going to change the sign on the whole matrix. And that will give us our solution matrix. Okay? So, again, if this were me, I would map it all out using my guide here. And then I would do the multiplication to get rid of these scalars. Just do that first, and then move things adding and subtracting, and then anything that you've got to multiply or do, that would be the last thing I'd do. Okay? So let's just see if we've got anything that might be a little bit more complex. Here you're just doing half. If you get fractions, by the way, just keep your answers fractions. So this is saying you want the opposite sign of A, the negative of A. So I would go ahead and do the opposite sign. Because there's no reason to put that negative in the front. We can go ahead and distribute the negative. To that, you're going to take half of an unknown, which we don't know. And then here, I probably would go ahead and take half a B. There's sometimes when it's important that you write everything out. Sometimes you could do it just based on what you've got. Okay? So then again, to move this first matrix A, I would subtract it over here to move it. answer. So negative 4 minus negative 11 is negative 4 plus 11, so that's 7. And 4 minus 8, negative 4. 5 minus negative 1, and negative 4 minus 4, negative 8. Okay? And then, if we're multiplying by a half here, we could multiply by the reciprocal to get rid of the half. So we can multiply by 2. And our final matrix X would just be this times 2. Okay? So I map it all out first if that's better for you. Go ahead and take care of scalars if that is better for you. But at some point, I probably would not try to keep it all in my head and try to do it at once. Okay? Because it will get complicated as you go. Alright? So that is solving with matrix.